You may have noticed on your calculator two buttons that we haven't used yet, one called log and one called ln. What those represent are logarithmic functions, which we're going to do in this lesson. A logarithm is an inverse function for the exponential functions that we looked at. And so two inverse functions of one another are the exponential function and the log function. And what I mean by inverses is just like a square and a square root are inverse functions of each other. A cube and a cube root are inverse functions of each other, those types of things. So the exponential function that has the x in the exponent, the inverse function of that isn't any kind of root, but it's called a log. And so the definition of log is easier to show just by writing it out and showing you how it compares to a exponential form of the same thing. And so what we have here is log, and for every log is attached to a base, which is a sub number. It's at a lower level, and then the thing that you're taking log of, or the thing that you're doing the function to, is the a in this case. It can be called other things. Some people put x there. But we're doing log to the a, and we're doing it at a base of b specifically. And so this is called the base, and we read that log base b of a. And so you always just say log base whatever, and then make sure you realize that the log and the a are on the same level, and they're on the same level as whatever the number is over here. So they're all on the up, normal level, and the b is dropped down. So the way that logarithms are defined is that log base b of a will equal some number x only if b to the x power would equal a. And that literally is the definition of a log, that log base b of a will equal x only if b to the x equals a. Sometimes it's easy to get these out of order and forget how they're rearranged. And so one thing I do, and this is the reason I use a and x where I have them, is I just say log backs. So log backs. And if you can remember BAX, just remember log BAX. Then it will help you to remember that b is the base, and the base of the log is the same thing as the base of the exponent. So the base is the base. Then the A stands for answer, because after you take b to the x, you get an answer, and so your answer is actually going to be the thing you're taking the log of. And then I put x over here just because the answer to a log is actually an exponent. So the x becomes the exponent. So the way that I remember is you do log backs, and then that means b is the base, a becomes the answer, and x, and I just say x for exponent, x is the exponent. So hopefully that might help you arrange them properly on the next pages. There's a few rules about logs that you need to understand, and kind of some things that have to happen for a log function to be defined, because it's not defined everywhere. Sometimes it's undefined, and so we need to kind of state what those are. A has to be greater than 0, which means it has to be positive, and it can't be 0 or negative. And b also has to be positive. And then one more stipulation we have on b is that b cannot equal 1, because if b equals 1, that would be a base of 1 with different exponents on it, and 1 already is kind of a unique base, because if you have 1 to the second, you get 1. If you have 1 to the third, you still get 1. If you have 1 to the 100th, you still get 1. Because 1 times 1 times 1 times 1, no matter how many times you do it, is still 1. And so because of that, b can't equal 1 because it doesn't have the same properties as other bases. Some other things you should know about logs are that when you hear or see the word log, the spelling of that is, it's a logarithm. And a logarithm is the same thing as a log, but we usually just don't ever use the longer word. You'll see the shorter word even said and written a lot more than you'll see the long word logarithm written. The second one is on your calculator. It's an ln, and we'll get into this in a future lesson, but I just wanted you to know what it was while we were here. And this is called a natural logarithm. The reason it's called the natural logarithm, and I know that these are backwards, but instead of NL, they decided to write LN, but it means the natural logarithm, and you may remember that the natural number or the natural base that we talked about, the natural number was e, and so the natural base was e. When we talked about exponential functions like e to the second, that was a exponential function with, like if we put a y in there, y equals e squared was a base of e, and that was called the natural base. So when you see an ln, like this one here, that's attached to a number, so ln of 5, there's an understood base of e there, and so that is the same thing as if we had said log base e of 5. And remember, e is not a variable. E is the natural number. It always means the same thing, and it is, you can find it on the calculator. It's a standard number that's always the same thing, 2 point something, and that 2 point something is always e. So you'll see, you won't see this written, because if it were log base e of 5, they would write it ln of 5. And so they'll drop the base e and just change the letters to ln for natural log. Then, if you see a log that does not have a base, and it does say the word log, but it doesn't have a base, there's one base that's assumed, and when it doesn't say what base it is, you assume that it's a log base 10. So this actually means log base 10 of 4. And when it has no base at all, it's an assumed 10. So when we talk about base e, we're talking about in an exponential function, that's the base of the exponent, so that's a base e. And then when we're talking about it as a log, it's base e down in the subcategory underneath the log of 5. It's log base e of 5. And you're not going to see that e ever written there because they're going to change it to ln. But that's what we're talking about when we're talking about base e. The most common log is your common log, which is log base 10 of 4. But you can have log base 3 of something. So we'll say log base 3 of 5. The number can be anything as long as it's not 1 and as long as it's positive. But the most common ones are the two that we have here, and that's why we have special calculator keys for log and ln. So let's look at some ways that you could be asked a question about logs before we actually get into graphing them or anything like that. First, let's look at writing something in logarithmic form. So if something's in an exponential form as a statement and you want to rewrite it in logarithmic form because there'll be uses for that once we are trying to solve for variables. But let's just practice it with all numbers involved. So 3 to the 4th is 81. That's a true statement. And so what we're going to do is we're going to take that exponential form of a statement and we're going to switch it over to log form. And so remember how it goes. You write the word log, and then remember log backs. So the base is the same as the base of this. So the little number at the bottom is a 3. And then it's BAX, so the answer goes next. And it equals the x, which is the exponent. So log base 3 of 81 equals 4. And make sure, some people start making this part look like it's 3 to the 81st power, but you want to keep your 3 little because it's just a little base. It's not the base of an exponent. It's a different kind of base. It's the base of the log. So this is a log base 3 function. You're taking it of 81 and it equals 4. So that is how you should write it. The log, the 81, and the 4 should all be on the same level as large numbers, and then you should have a small 3 kind of almost attached to the word log because it's a log base 3. That's what that function is a log base 3. You can have fractions. It doesn't always have to be whole numbers. So if we had something like number 2, we would say log, the base is 2/3. So make it kind of like a little 2/3. And then the answer goes next, and the answer is the 8/27. And when it's complicated looking like that, like if it's anything that's more than just a whole number, I would put it in parentheses. So you're taking log base 2/3 of 8/27, and your answer is the exponent. So that's the exponent. So just think about what this is saying. If you do the log function at base 3 to the 81, you get the answer 4. So 4 is the answer to log base 3 of 81. If you take log base 2/3 of 8/27 and do that function, your answer is 3. So hopefully you have a little bit better understanding of how the log function is going to look as compared to an exponential form of a statement.